Okay, so hello everyone. Today I'm taking us on Laplace transform. This is actually the second tutorial. In the first tutorial, I attempted a very general question in Laplace transform, although I did not address the introduction aspect. For now, I wouldn't want to bore us with the introduction aspect, so let's leave that for later. So the question I attempted the last time was the Laplace transform of e raised power at. Yes, you can check my previous tutorial on that. So this time around, I want us to see the Laplace transform of a number, for example, Laplace transform of 2. So let's see the Laplace transform of 2. Now, based on the general formula, we remember that the Laplace transform of a function L of a function f sub t, where f sub t is the function, is actually this. So this is the general rule for a Laplace transform, and I discussed that a little bit in my previous video. So you can check my first tutorial on Laplace transforms for that. All right, so let's put that aside. Now let's proceed. Using that general formula, the Laplace transform of 2 will be, since 2 is f sub t, f sub t, sorry. So f sub t here is 2. F sub t is 2. So we want to find, okay, let me just say this. At the end of the tutorial, I'm going to ask a question and I want you to drop your answer in the comment section. Now let's proceed. So f sub t is 2. According to general rule, we have the Laplace transform of 2 to be the integral from 0 to infinity of e raised power minus st. Now f sub t is 2, so we have dot 2 dt. That will give us, now integrating this function here, the best way to proceed would be to, now since we have two variables here, we simply bring out the 2. We bring out this, and then we'll have equal to 2 integral from 0 to infinity e raised power minus st dt. That will give us 2. Now the integral of e raised power minus st, let's do that on a separate page. The integral of e raised power minus st is e raised power minus st divided by minus s. We simply divide it by this. Therefore, we have this to give us, we open our brackets, e raised power minus st over minus s. Now, the t is no more there because we've integrated. What we now have left is from 0 to infinity. That will give us 2. Now, we can simply bring out this minus s by saying 2 over minus s. Then we'll have, open brackets, e raised power minus st. Now, because we have the upper limit of infinity and the lower limit of 0, according to integration, we take the first one and raise it to power infinity. So what we have is infinity, then minus e raised to power minus st, then 0. Then that gives us equal to 2 over minus s. Now you have to take note of two things, which I will show you. E raised to power infinity is 0. I've already established this in my previous tutorial, but just for emphasis sake, and e raised to power 0 is 1. So we're going to be applying this in our solution. Here we have e raised to power st multiplied by infinity. That will give us e raised to power infinity. Then here we have e raised to power st, then multiplied by 0. That will give us minus e raised to power 0. Therefore, we have equal to 2 over s in bracket. Now, I already told you e raised to power infinity is 0, so we have 0, and e raised to power 0 is 1, minus 1. Then we close our bracket. That will give us 2. No, sorry, I skipped this minus. 2 over minus s in brackets minus 1. Now that is going to give us now the minus 1 is going to attack the up. So we have minus 2 over minus s. And so the minus goes with this minus, and what we have left is 2 over s. So basically, the Laplace transform, generally speaking, of a constant is actually k over s. And I'm going to do a tutorial just to show us the standard Laplace transforms, their formulas, which you can use to get the solutions to this without having to go the long way through. So the Laplace transform of 2 is actually 2 over s. Okay, so here we have a table for the formulas when it comes to Laplace transforms. On the left side here, we have the functions, and on the right side, we have the Laplace transforms. So for the first function, if you remember very closely, e raised to the power at, this is what we derived according to the first tutorial. For the second function, which I have not done a tutorial on, in case you want me to do a tutorial on, I might show us on that. This is what we have for the second function. Same way, and the same way we have for all of these functions, we have their Laplace transforms here on the right hand side, so that you can directly apply these rules, these formulas, instead of having to prove them by first principle. That way, when you're given a question, you can directly apply the formulas to get the answers. This is very, very important. I will suggest that you write this table down. It's very important. So I'm going to show you the whole page so that you can write it down. And I'm going to highlight some major ones we come across every day in textbooks. For example, the one I did in the first tutorial. This is more likely. Sorry, this is more likely. This, and then in fact, the first four are not avoidable. Down to this, you just have to. Sorry, I'm making a mess of all this. I'm just trying to highlight major ones that you come across. That way, you can know what to commit to memory. I would suggest you commit those ones highlighted. You commit them to memory. They're very, very important. They're very important. So now I'm going to go to the next page for you to see something. Have a look at this. I want you to see three things here. This. Look at these three things here. These are very important when we are going to attempt the inverse Laplace transforms. I'm going to do a video on that, inverse Laplace transforms, and you may need to write what I just highlighted now. You may need to write it down and commit it to memory because we're going to be using it a lot. Now, there is the derivation process, but I'm not going to cover that unless you guys suggest for it. I'm not going to cover that. I just want you to see some very important things in the tables that you may need. So that will be all for this video. If you have any question, please you can drop a question in the comment section and we'll address that as soon as possible as time permits. Thank you.